Now we're going to talk about synchronization primitives. This topic has enough things to cover a complete course, so we are not going to dig into every single detail because it will take us forever. So we are going to just make a quick overview, give some code examples, and then I'm going to do some further explanation on the practical examples from the module 4. But please try to do your own research if you feel that you need some more details. And there are plenty of classes that have more granular synchronization or more flexible synchronization for any kind of need. Again, this is a very complex topic, so you will have to dig a little bit on your own about it. So the first thing we're going to cover is the lock sentence. So I'm going to quickly show you. We're going to create a new solution for testing the synchronization primitives. It's going to be a console application called SyncPrimitives test. First of all, we're going to create 2 threads in our main thread. These threads are going to call the do some work method that it's just going to first check which one is the first thread. Then if it is the first thread, I'm going to set it as false, and it's going to sleep for 3 seconds. Basically, the idea here is that we need to make some time between the first thread and the second thread, because then they are going to iterate with the for loop. Then they are going to access shared resource and assign to it the integer from the loop. Then they are going to make brief sleep. Then we are going to print in the console the information of this point in time. We are going to display the thread name from the current thread. We're going to show the status of the shared resource and the value of this particular moment in the loop execution. This variable doesn't exist yet, so we're going to create it. Now we're going to create the second thread here, and we are going to start the threads. Finally, we're going to wait for user input so we can see the behavior of the program. So here we're going to put thread name, shared resource status, and finally the loop status. We're going to initialize this variable. Here we're not able to access this variable. Okay, there's a typo here. Okay, so we are ready. Let's see how the program behaves. Okay, we forgot to set the thread name. We're going to set it here. In this nice feature of properties initializers. We need to initialize this variable as true. So let's see how it goes. Okay, so let's see the beginning of the execution. At the beginning you see that thread 1 starts iterating, and when it reaches the value 28, thread 2 starts the execution and sets the loop status equal to 0, but the shared resource is equal to 30. So you will see that at the second line here, thread 1 is in the loop status number 30, but the shared resource has the value 1. This is because this is the moment when thread number 1 has set the shared resource with its own value. So this is just to make a simple example of how two threads can get into conflict if they are accessing two shared resources without any synchronization. So now I'm going to show you how can we avoid this situation. I'm going to stop the program and I'm going to present you the log sentence. So when both threads access the same piece of code that touches the shared resource, we are going to log an object. It's going to be called object log, and we are going to surround our code with this structure. We're going to create the logged object to be a private static object. This can be any kind of object. We're going to use the object type because it's the most lightweight. Now that we are looking here, none of the threads is going to access this piece of code until the other thread releases the log. So let's see how it goes. Okay, so as you can see here, the behavior now is that the threads are entering this piece of code one at a time. So when thread number 2 finishes, then thread number 1 acquires the lock after thread number 2 releases, and thread number 1 starts iterating. So now we are going to make another test. I'm going to move this lock statement inside of the for loop so we can see more granular locking and see how this behaves. As you can see, both threads start overlapping in the sequence of execution, but now you will never see that there is data corruption. The operation of writing the shared resource and reading it for printing it into the console buffer is an atomic operation. So now you can see that every time thread number 2 writes the value, it's in sync with the loop status. So even if thread number 1 is in the execution number 32 and thread number 2 is in the execution number 3, they will never overlap. So here we have fixed the data corruption issue. Okay, now I'm going to show you what happens behind the scene. Let's stop the program. I'm going to comment this piece of code and I'm going to make the same method but using the monitor object, which is what the framework is doing behind the scenes. So first of all, we're going to convert this into a try structure. and we are going to call system threading monitor enter method. We're going to pass a parameter with the object locked, and we're going to create a bool variable that is going to indicate if the lock has been taken. After this, we are going to add a finally block, and if the lock was taken, we are going to call system threading monitor exit, passing the lock as a parameter. Let's see how this goes. So we should be seeing here that the code is behaving exactly the same way as it was. You can see that we still have atomicity in every operation while writing the shared resource and reading it. So now I'm going to give you some advice on some things you have to take into account while you're using the lock structure. First of all, you should never use type instances as an object for blocking your threads. If you use a type instance, there's the chance that another program or process or thread is also doing the same, and you can enter in a deadlock with a different program. Another thing you have to take into account is that you cannot use the await operator inside the lock statement.